Hello, good morning. Any questions from the previous class? Sorry, can we? They are radioactive. Decay will be a better word. Disintegration often means division of a larger object into smaller things. So in this case, often we use disintegration for nuclear fission. A better word for radioactivity is radioactive decay. But yes, alpha, beta, gamma decay is radioactive decay. Even if I call it radioactive disintegration, that will be fine. But decay will be a better word. Any other question? Yes, I haven't talked about that. So I'm going to talk about application of nuclear technology in defense. And we'll have more discussion about that in defense technology. Sorry? हाँ हाँ ओके तो क्वेश्चन ये है कि जो बीटा पहले तो दोनों में ही Z+1 नहीं होना चाहिए. ये बहुत क्लियर होना चाहिए कि दोनों में ही Z+1 नहीं होना चाहिए. क्वेश्चन इज आस्किंग इज जो बीटा डीके है वहां पे एटॉमिक नंबर इंक्रीज्ड बाय 1 एंड आई टोल्ड यू दैट देयर आर two types of beta. In fact, there are three types of beta decay. But let's talk about two types of beta decay. In one, which electron gets emitted, another positron gets emitted. The question is that why in both the cases you have the same result. This reaction happens into 2-3 stages. It's not Z suddenly becomes Z+1. It happens into 2-3 stages. I only wrote the end result. So, जो बीच के intermediate stage हैं, in case of electron emission, in case of positron emission, they are different. And even though the intermediate stages are different, the final stage is exactly same. That the atomic number increases by 1 and atomic mass remains the same. We do not have to go into those intermediate stages. Just remember that beta decay does produce another nucleus, an isobar, where atomic number increases by 1, nothing happens to atomic mass. Any other question? Nuclear transmutation means whenever one nucleus is changing into something else. Transmutation as a word means that there has been a sudden change into something else. Just I can use the word nuclear transmutation for alpha decay or beta decay. That I started with uranium, but I got thorium. So that will be transmutation. Isotopic separation method means that I have a mixture, but this is not a mixture of two different things. It is a mixture of same element, albeit with different atomic mass, and I want to separate them, hence the word iso. So yes, these are two entirely separate words, nothing to do with each other at all. What is the assumption? What are the assumptions on which carbon dating works? Any assumptions? The first assumption here is that carbon 14 and carbon 12 ratio has not changed a lot in last few thousands of years. ये सबसे पहला assumption ये है that carbon dating work करने का, that the ratio of carbon 14 and carbon 12 in the atmosphere, that has not changed a lot. And why we assume that? Because on an average, the amount of neutrinos which bombard the upper atmosphere, they do not appreciably increase or decrease. Even if there is a marginal increase or decrease, on an average, let's say for example, I do this calculation for 1 year, then that number will be more or less the same. So the amount of carbon 14 which is being made in the atmosphere, that is also more or less the same, and the amount of carbon 12 which is in the atmosphere, that has also not changed appreciably. Of course it has increased a little bit because of global warming, but more or less carbon jo 12 hai, that has also not changed that much. So that is why this ratio carbon 14 and carbon 12 has not changed a lot. That is the first assumption. The second assumption here is the same ratio is also found in living organism, but this assumption can be verified. The first assumption we cannot like go and experimentally confirm. अभी हम बस confirm ये कर सकते हैं, हम एक estimate कर सकते हैं, हम अभी का calculation कर सकते हैं, देख सकते हैं that within 1 year neutron, how many neutrons, all of those things, but we cannot go and see what happened, let's say 50,000 years ago. But this assumption can be verified, that whatever ratio carbon 14, carbon 12 is in the atmosphere, the same ratio is found in living organisms. That assumption can be verified. That's very simple. Take any living organism such as us or plants or anything, animals, and analyze how much carbon 14 and how much carbon 12 is there. And yes, that analysis can be done. And you can confirm that. And turns out this assumption is true. So yes, there are few assumptions. Carbon 14 dating will not work in many cases. I already have told you, if your fossil is very old, more than 100,000 years old, carbon 14 will not work because carbon 14 has a very small half-life. Now you may think that 5800 years is not small, but you have other isotopes jinka half-life is in 100,000 years or 500,000 years, and they will be better for those fossil which are much older. Carbon 14 can only tell you that something on a sample, when was something alive on a particular sample. Maybe that sample in itself is older than that. But carbon 14 can tell you that when was something last alive on that particular sample. So there are limitations, but nonetheless, it is one of the most powerful tool for aging of fossil. तो मैंने बस एक वर्ड यूज किया था, आइसोटोपिक सेपरेशन मेथड. आप क्वेश्चन आपका ये है कि इनरिचमेंट में हम 235 का कॉन्सेंट्रेशन कैसे इंक्रीज करते हैं. जैसे आप ऐसे समझ लो दैट आई गिव दिस एग्जांपल टू समबडी, किसी ने क्लास के बाद भी पूछा था, दैट आई हैव मिल्क एंड उसमें वाटर पोर कर रखा है एंड आई वांट टू, सो राइट नाउ लेट्स से फॉर एग्जांपल द मिल्क्स कॉन्सेंट्रेशन इज 95% and 5% water is there. So I need to remove that water. So once I remove this, so for example, let's say I have two sample. One has let's say, or one sample only, that I have 50-50 water, 50 gram of water, 50 gram of milk. So total I have a mixture of 100 gram. What is the percentage of milk? 50%. Let's say I remove 10 gram of water from there. So now I only have 90 gram, but within that 90 gram, I have 50 gram of milk. So percentage becomes 50 by 19 to 100, percentage increases. So we have to do the same thing, that we need to remove uranium 238 so that the percentage of 235 in the sample, it increases. But it's easier said than done. My point here was that milk and water separation, that's simple. Two different things, we can do that. But uranium 235 and 238, they both are uranium after all. The only thing is that their atomic mass differs, and separating them is much more difficult. That is something, how do we separate it? What are the actual processes which is done to separate them? We do not have to go into that detail. Any other question? बहुत बढ़िया एटॉमिक बॉम्ब नहीं होगा. एटॉमिक बॉम्ब जैसे अगर आपका इनरिचमेंट परसेंटेज एज लॉन्ग एज 20% है तो हम उसको बोलते हैं लो इनरिच्ड यूरेनियम. When enrichment percentage increases beyond 60%, we call it high enriched uranium, 20 to 60 medium enriched uranium. Ideally, we would want atomic bombs to be made from high enriched uranium if you want a much more effective atomic bomb. So enrichment percentage ideally should be more than not 20%, but 60-70% is also good, but the most powerful atomic bombs will be in enrichment of more than 90%. Any other question? There are a few questions here. I was studying beta decay. There was a term called anti-neutrino. We will talk about neutrino because India is working on an Indian neutrino observatory. Neutrino research is one of the most interesting thing which is going on across the world. So we will talk about neutrinos, and there I will also mention about anti-neutrino. Not right now. How Einstein's mass energy formula is used in both cases, because fissile material mass will be more, and we know fusion releases energy 4 times. So mass energy formula is used when I wrote the equations. For example, I wrote about 411H, 42He. So I am basically approximating that to be 1 proton ka jo mass hai, I am approximating that to be 1 atomic mass unit. And 1 neutron ka jo mass hai, I am approximating that to be 1 atomic mass unit. I told you in the last to last class itself that both proton and neutron, they have mass more than 1 atomic mass unit, little bit more. And technically, neutron is more massive than proton. So neutron's mass is more than proton. But that difference is so small that we neglect it and we say that everything is just 1 only. But when we will do calculation is equal to mc squared, then we will go into those exact figures. That proton ka mass kitna hai, neutron ka kitna hai, and then we go and subtract the mass of product, and we find this to be a positive number. Do we need to learn about positron? In a sense, you need to know that positron is antiparticle of electron. And what does the word antiparticle mean? I will discuss that. Can graphite be used as a moderator? Some people have done that. In fact, Chernobyl reactor jo tha, Ukraine ka, that actually used graphite as a moderator. Turns out that graphite is not a very good moderator. It led to leakages of neutrons, and those leakages actually allowed that reaction to become uncontrolled, and that led to this explosion in the Chernobyl reactor, which I was talking about in the previous class. So yes, graphite can be used as a moderator. It has been used in past as a moderator, but there are challenges in use of graphite as a moderator. In current affairs, science and technology, India had successfully conducted second landing experiment of Pushpak, not Pushkar, Pushpak. So Pushpak reusable launch vehicle, this type of info is useful. It is useful. Whatever ISRO is doing is important for examination. And Pushpak is important because I was talking about the concept of reusable launch vehicle. So I also told you that ISRO is planning to make a reusable launch vehicle. So ISRO is conducting series of experiments. And a second experiment which happened just in fact 2 months ago, that ISRO dropped a vehicle from very high altitude and was able to recover that completely unharmed. And this vehicle was called Pushpak Viman from Ramayan. So Pushpak jo hai, that actually is the reusable launch vehicle, a technology demonstration. तो अभी हम step by step आगे जा रहे हैं. अब next में हम क्या करेंगे? We will perhaps use it on a rocket and then we will try to recover it. अभी हमने हेलीकॉप्टर से प्लेन से ड्रॉप किया था. So we will keep increasing the stake of the experiment. We will learn the challenges and accordingly we will try to overcome those challenges. So yes, the जो news पुष्पक वाला जो news है वो important news है, particularly prelims exam के लिए. Any other question from? आज हम इसी पे डिस्कस करेंगे हम. In fact, let's start today's class with applications in space technology. इसरो ने, प्लीज डोंट टॉक, इसरो ने चंद्रयान 1, 2, 3 लॉन्च किया है, मार्स ऑर्बिटर मिशन लॉन्च किया इन पास्ट. What was the power source of Mars orbiter mission? Like where was it deriving its power from? It needs to collect some data, send that data back to Earth. For that it needs energy. So what was that source of energy? Solar. Goes without saying, it is solar. Solar panels are part of your spacecraft. Those solar panels provide you necessary energy so that you can collect data and send that data back to Earth. NASA had sent many missions throughout solar system. Many missions on Mars, missions which have been onto Jupiter, to Saturn, even to Kuiper belt, जो Neptune, Pluto वाला region है. But NASA has 2 missions called Voyager 1 and Voyager 2. What is unique about Voyager 1 and Voyager 2? Does anyone know? What is unique about these 2 missions? Perfect. They're not even part of the solar system as of now. These are the only 2 man-made objects which are not part of the solar system. As of now, they were launched about 40 years ago. And in that 40 year, they went through all the planets. They went through Oort cloud, and they, as of now, are not even part of the solar system. But NASA still has a deep network of antennas, very powerful antennas, and it can receive very faint signal. In fact, both of them were in news in last few months. For a brief duration, the signal was lost. There were some problems in the signal processing, and NASA has rectified those problems. So because of that also these two missions were in news. Launched 40 years ago. Now I have a question that what is the source of energy for Voyager 1 and Voyager 2? Because they are not part of the solar system. So this is where nuclear technology comes into place. Nuclear technology has some amazing applications into space technology. And first application here is that all the missions which go into deep space matlab very far away from Earth. So yes, you can rely upon solar energy, and solar energy will be the most important source. But let me rectify that. You cannot rely upon it. How you cannot rely upon it? Because solar energy is not permanent. There will be places in space which will go through complete darkness and you do not have any source of energy. And let's say you have a battery, that battery needs to be charged with the help of solar panels. But if you do not have sun energy, solar energy, then those batteries will be discharged. Forget about sending data to Earth. You will not be even be able to collect any data. So that is a challenge. Solar energy cannot be relied upon. And in fact, the more you go far away from sun, the reliability only decreases. And if you're not part of the solar system, which by the way, what Voyager 1 and Voyager 2 are, then solar energy is not even a source of energy. In that case, you come to a technology which is called radioisotope thermoelectric generator. So the first application of nuclear technology in space, write it down. Radioisotope thermoelectric generator. So what we will do in such spacecrafts, in a central chamber, we will keep plutonium and one of the isotope of plutonium, which is plutonium-238, not 239. We talked about plutonium-239 in previous classes. In nuclear program of India हमने discuss किया था. Another isotope of plutonium is plutonium-238, and plutonium-238 undergoes alpha decay, releases alpha particle. Plutonium का atomic number 94 है, so once it releases alpha particle, atomic number becomes 92, which is nothing but uranium, and it becomes 234. So it produces another isotope of uranium with atomic mass of 234. But it also, that alpha particle is released with a lot of energy. So a lot of energy is produced in this reaction. So now what we do here is that in the central chamber, surrounding a material which will isolate the central chamber with rest of the scientific equipments. But that chamber के जो walls हैं, they will be made of those materials which can absorb that heat energy as part of alpha particle. And they are made of materials which can convert that heat energy into electrical energy. We can do that. There are materials which can convert thermal energy into electrical energy. So, and hence the word here, radioisotope. So what is radioisotope? This plutonium-238 is radioisotope, which is being used to produce heat energy. That is the word thermo means here. But that thermal energy is now being converted into electrical energy, hence the word thermoelectric generator. So this spacecraft, such as let's say Voyager 1 or Voyager 2, and dozens of missions of NASA or even European Space Agency, they have been launched using this technology called RTG, radioisotope thermoelectric generator, where in the central chamber they keep radioisotopes such as plutonium-238, and that plutonium-238 releases heat energy because of alpha decay, and that heat energy can be absorbed by the materials of the spacecraft and can convert that into electrical energy, and it can charge a battery, and जो आपका spacecraft है, it is going to be operational. The beauty of this technology here is that we do not have to rely at all upon solar energy. No matter where you are, it is going to produce energy. And the second benefit here is that इसका जो half-life है plutonium-238 का, if I'm not mistaken, it is about 80 years. What does that mean? That even if I start with 250 gram of plutonium-238, then even after 80 years, I still have 125 gram left. So I can have a mission which can go on for decades, and I do not have to worry at all about source of energy. that source of energy is decay of plutonium in this particular case. So this is a very popular technology used by agencies such as NASA. NASA particularly has launched many missions to Mars or to Jupiter or towards Saturn using this technology. ISRO has not used this technology till now. But I did come across a news 2-3 years ago, not part of current affairs per se, that ISRO is actually planning to develop something like this. ISRO is working on this capability that maybe for future space missions, we will be using this technology. तो आप एक लाइन में लिख सकते हो. For deep space missions, for deep space missions, for deep space missions, space agencies rely upon solar energy, or space agencies use solar panels. Space agencies use solar panels. Solar panels generally. However, solar energy is not a reliable source. However, solar energy is not a reliable source. Solar energy is not a reliable source. RTG, radioisotope thermoelectric generator, RTG utilizes decay of plutonium-238. RTG utilizes decay of plutonium-238 to produce thermal energy which can be converted into electrical energy. To produce thermal energy which can be converted into electrical energy. Which can be converted into electrical energy. This technology is very useful for deep space exploration. This technology is very useful for deep space exploration. Deep space exploration. Deep space exploration. This technology is very useful for deep space exploration. You can give the examples Voyager 1, Voyager 2. I will repeat, but not limited to these two. NASA has launched dozens of their missions to the solar system using this technology. And I will also repeat, ISRO has not used this technology till now. हमारे जो भी missions हैं, till now they have relied upon जो भी astronomical missions हैं, lunar missions हैं, Martian mission हैं, all of them they have utilized solar panels only. But ISRO is working towards this, developing, using this technology for perhaps future mission. The second application is called nuclear propulsion. Okay, so before I explain this, I should tell you a very important fact here, that there is not a single space agency which have a rocket, functioning rocket using nuclear propulsion. It is in experimental stages. So nuclear propulsion simply means that rather than relying upon the solid or liquid fuel, burning of fuel, solid fuel or liquid fuel or cryogenic fuel, why don't we rely upon nuclear fission? That you have a very small reactor, part of the rocket itself. That reactor can produce a lot of heat energy. That heat energy can heat up gases which will come out of the rocket, and rocket is going to accelerate. The beauty of this system here will be that even with very less amount of fuel, we will be able to generate huge amount of energy. So to propel a rocket, let's use nuclear fission. NASA thought about this in 1970s. Very soon, because of practical limitations, they abandoned that plan. And I came across a news last year that they have again revived that plan. So in 2023, there was a news that NASA again has revived that plan, and they are working on developing a rocket which will be using nuclear propulsion. Now, such type of rocket which can use nuclear propulsion will be particularly very useful for missions, manned missions, which, let's say, go to Mars and they have to come back. So first of all, I hope that everybody is clear that SpaceX, for example, has this plan that we want to colonize Mars. जो Elon Musk की company है, उनका एक plan है that we want to colonize Mars. But that will be one-way mission, that you go to Mars, you stay there. So the same way, it is very difficult to launch from Earth. It is very difficult to come back from Mars. Mars is a smaller planet compared to Earth, but nonetheless, it is going to be very difficult. And Mars, as far as we know, there are no fuel sources available at Mars. So for return missions, let's imagine now a manned mission, which it's supposed to return back to Earth. For a return mission, you need to carry all of that fuel from Earth itself. But that will make your rocket very heavy, which will be quite difficult to carry all of those things and come back. And that is where nuclear propulsion can play a very important role. That even with very small amount of fuel, we can land something to Mars and we can come back. So we have a rocket which is not that heavy because of nuclear propulsion, and it can have a bidirectional mission from Mars and again coming back to Earth. I will repeat, all of that remains in experimental stages. There is not a single rocket which has achieved this capability. आप लिख सकते हो? Using nuclear energy for propulsion of rocket. Using nuclear energy for rocket propulsion. For rocket propulsion. This remains in experimental state. This remains in experimental stage. This remains in experimental stage. Applications in defense. Atomic bombs or hydrogen bombs, which we talked about earlier. Another very popular application is nuclear submarines and ships. I will be talking about submarines in defense technology, but I hope everybody already is clear about submarine. We are talking about a water submersible vehicle. But a water submersible vehicle requires some sort of engine to operate. Often we use diesel electric engine. The problem with diesel electric engine is that it needs oxygen. Without oxygen, diesel is not going to burn. And because of that, it needs to come on the surface from time to time. And that is not what submarines are known for. Best submarines are if they can stay inside water for very, very long. Because while they are inside, deep inside water, enemy ships and submarines will have very difficulty in knowing about their location. And they can work secretly, they can gather information, intelligence, all of those things. But if they are on the surface, then they are vulnerable to a flying radar, to planes, to other ships and submarines. We do not want that to happen. And that is where nuclear submarines comes into place. A nuclear submarine, for example, India has a nuclear submarine called INS Arihant. I will be talking about that in defense technology. So INS Arihant hai, that has a small nuclear reactor inside the submarine itself. It is a pressurized water reactor, and whatever energy requirement is required for this particular submarine, it comes from nuclear fission. And fission does not need any oxygen. So technically, as long as you have enough oxygen, drinking water, all of those things available for the crew inside that submarine, it can stay inside water for weeks, for days to months also. So the limitation now will not be oxygen requirement. The limitation will be how much food and how much drinking water and overall जो habitable condition चाहिए ऐसे tough situation में, that if you have all of those things available, then you can stay inside water for days to weeks to months also. So nuclear submarines give you a lot of capability in Navy. We will be discussing about this in defense technology even in more detail. India does not have a nuclear ship. जो हमारे ships हैं, none of the ships are nuclear ships, but US, for example, has many ships also, which are powered using nuclear reactor, small nuclear reactor. And one last applications I can talk about here is industrial applications. Industrial applications. Write down few things here. Let me explain this first. Industrial applications, what type of applications we can talk about. In many ways, nuclear technology has applications in industry. One of the most interesting application I can tell you is about material inspection, particularly solid material inspection. The same way we use X-ray to know about internals of your body. X-ray का property क्या है? That it can cross your flesh, but it cannot cross your bones, and because of that you create a shadow, and doctors can utilize that and they would know that if bone is fractured or something like that. We can use gamma rays for solid objects. Let's say I have a solid object. Let's say I have to analyze this wall here. Maybe there is some defect inside that wall. Maybe the person or the people who made this wall, they did not take good care of it, and because of that some void is left. Some part inside that wall is not solid, there is a void there. And that void makes this wall vulnerable to any type of disturbance. Let's say even because of small earthquake, this wall is not going to sustain. So how do I know about that void without actually breaking the wall? So let's use gamma rays for that. So the gamma ray scanning hai, that allows us to look inside even solid objects and to know if there are voids or any type of material defects inside object. That will be one application. Another very interesting application is that I have to find leakages on a very large pipeline. जैसे मान लो किसी natural gas company ने या oil company ने, they have installed hundreds of kilometers of pipes for supplying oil and natural gas. And even if there is one small leakage somewhere, it can be dangerous, it can be problematic. So how do we know about that leakage here? That there is some leakage on a pipeline which spans hundreds of kilometers. That's also very simple with the help of radioisotope. Use a radioisotope in which at normal temperature and pressure exists in gaseous state. So just allow that radioisotope in gaseous state inside that pipe. It is going to cover all of that pipe very soon. And since it is a radioisotope, it will be emitting, let's say, beta decay. Let's say it emits beta particle. There is a device called Geiger counter. Geiger counter ka purpose यही होता है that it measures alpha particle or beta particle. That the more number of beta particle it receives, it beeps more and more. So all you need to do is take a Geiger counter and roam through this entire pipeline. And the moment you are near the source of leakages, it will start beeping more and more because it is receiving more and more beta decay. And jitna beep fir badhega, that means that is your leakage source. So such type of application is called tracer, that we can use this to trace particular type of leakage, and such radioisotopes are called radio tracers. So radio tracers have even applications inside human body, that let's say, or in plants also, that what scientists do here is that nitrogen जो है, मान लो कि हमने nitrogen use किया fertilizer की तरह. Everybody is very clear that urea is a nitrogen based fertilizer. Let's use one of the isotope of nitrogen, nitrogen 13. Nitrogen का जो atomic mass है 14 है, but there is an isotope of nitrogen which has atomic mass of 13. It emits beta particle. Let's use nitrogen 13. And as this plant absorbs, and plant is going to absorb both nitrogen 14 and nitrogen 13. But as that nitrogen 13 gets emitted, that nitrogen 13 all the time is emitting beta particle. And I have a device which can record this beta particle. So what is the movement of this fertilizer? Where does it go into plant? How does it spread into rest of the plant? All of that we can record with the help of a radioisotope. So such type of applications where with the help of radioisotope, We want to understand about a specific process. We call these applications as radio tracing, that with the help of radioisotope, I'm tracing something. I'm trying to know about, understand about a particular process. This is also an application. There is a very interesting application in water desalination. Water desalination is something where all across the world we have to think about it. India definitely has to think about it because we are suffering from water scarcity. In many areas it is already water scarcity. And on an average, entire country is suffering from water stressed condition. This part I hope everybody is clear that the groundwater resources, they are depleting for us. What is the solution? Solution is to desalinate ocean water. Now, desalination can occur via two mechanisms mostly. First, you use some sort of filtration, some sort of membrane which can filter ocean water. The problem is that ocean water has such high salinity that membranes will have to be very good, and in any case they will not work for very long. All the time you have to keep changing those membranes, and it will not be very good technology. It is going to cost you a lot. The other option here is that let's vaporize water. Let's think of a setup where in one chamber I have millions of liters of water. I vaporize that water and allow that water to go to another chamber where we are going to condense that water. So salt is not going to vaporize, salt will be left in the first chamber and the water vapor will be condensed into the second chamber, that will be fresh water. The problem is that to do that for millions of liters of water, I need a source of energy. And if that source of energy is coal, then it's not good because burning coal causes so much of pollution, global warming, all of that problem. So let's use nuclear technology. That wherever you have nuclear reactor, near to that nuclear reactor, we also can have water desalination plant. And for water desalination, we can use that nuclear power. Nuclear power is a clean source of energy, does not emit greenhouse gases. So this is another way how we can do water desalination. And we will have to do something in this particular direction, given the fact that water resource is becoming more and more scarce all across the world. So there are many possible industrial applications of nuclear technology. Write down few of them. First, radioisotopes can be used. Radioisotopes can be used to trace the flow of fluids and gases in industrial process. To trace the flow of fluids in industrial processes. To trace the flow of fluids in industrial processes. In industrial processes. Next, gamma rays can be used. Gamma rays can be used to detect defects in solid objects. To detect defects in solid objects. Next, nuclear desalination involves nuclear desalination involves using nuclear power plants to provide energy for desalination process. To provide energy for desalination process. To provide energy for desalination process. Archaeological dating, one more application you can write about. Archaeological dating. Archaeological dating. All of these are possible applications of nuclear technology in industry. Any questions till now? We're done with this topic about nuclear technology. If you have any questions in whatever we have discussed, and let me summarize everything we have discussed. This topic is very straightforward. It's not a very complicated topic. Nuclear technology, first, I started all of my discussion with a very simple line that nuclear technology is essentially understanding of nuclear processes, that what is happening at the level of nucleus. The best thing here is that even if we cannot imagine it, human brain does not allow us to do that, but we can still use mathematics to understand the process. And using mathematical equations, we can understand the process, that what must be happening at the level of nucleus. And we can check that is our understanding correct or not. That is the beauty of science. Science always checks that whatever we are talking about, is it correct or not. Let's try to experiment that, experimentally confirm that. So when the first nuclear bomb was made, people were very sure that yes, it is something like this is going to happen. Manhattan Project, you may have read about that in America, you had this project called Manhattan Project led by a scientist called Oppenheimer. And Oppenheimer and his team led to the first atomic bomb. Now that happened for the first time. Nobody had witnessed nuclear fission, but everybody understood the science behind it. They knew that it is possible to have an uncontrolled chain reaction which is going to produce a lot of energy. So they knew about this because of the fact that they were very confident about the science they had developed. They knew the scientific process which allows them to understand how a nuclear process must function. So the understanding of nuclear processes, including reactions or decay, that is what nuclear technology is all about. And a major part of this entire discussion I focused upon that how do we use nuclear technology in energy production. I mentioned that how uncontrolled fission can lead to atomic bomb, but a controlled chain fission can lead to a reactor. We talked about what is India doing in nuclear reactor. We did a critical evaluation of nuclear energy. And then we talked about nuclear fusion, an exact opposite process of nuclear fission. And finally, the last part of the class, we talked about radioactivity, and we discussed that apart from energy production, what are other applications of nuclear technology in India. If you have any questions here, you can ask questions. बिल्कुल है. Climate change is essentially because of global warming, and global warming is essentially because of carbon dioxide, methane, N2O. And carbon dioxide, methane and N2O is essentially because of burning of coal, petroleum, natural gas. So because of our energy requirements, we are emitting a lot of greenhouse gases in the atmosphere, which leads to more built-up of heat energy in the planet system, which causes global warming. What if we can produce energy which does not produce greenhouse gases? Nuclear technology. So nuclear energy does not produce greenhouse gases. So bilkul hai, right? Yes, go ahead. Can't we use ocean water for energy production? Like what type of uses? हाँ, तो ये भी एक है, बिल्कुल सही बोल रहे हो. इनफैक्ट दिस इज समथिंग विच पीपल आर थिंकिंग अबाउट, दैट व्हाई डोंट वी यूज ओशियानिक वाटर. जो हम न्यूक्लियर रिएक्टर में वाटर का जरूरत तो है ही, सो वॉट एवर एनर्जी वी आर यूटिलाइजिंग, लेट्स यूज फॉर डिसैलिनेशन as well as for energy production, converting that water into steam. Yes, a lot of work is happening in this direction, that how to make this economically feasible. तो ये already इस पे काम चल रहा है, that how to do energy production, desalination, all of that simultaneously, or all of that together in an economically feasible manner. Okay. Write down a question asked by UPSC. एक क्वेश्चन हमने डिस्कस किया था, should India keep on expanding? हमने डिस्कस किया था ये क्वेश्चन. Write down one more question. Discuss the achievements of India. Discuss the achievements of India. Achievements of India in nuclear science and technology. in nuclear science and technology? What are the advantages of fast breeder reactor? What are the advantages of fast breeder reactor? Discuss the achievements of India in nuclear science and technology. What are the advantages of fast breeder reactor? I may have paraphrased this question a little bit, but this was what was asked by UPSC. I've just, like, I do not remember the exact formation, but this is what was asked. There is a question. I will give you time to answer this question, but there is a question here that can you please explain how gamma and beta radiation is linked to nuclear energy? Yes, I can. So think of uncontrolled nuclear fission at an atomic bomb. When an atomic bomb produces, it leads to production of lot of neutrons, lot of many other high energy subatomic particles, and those high energy subatomic particles can go and cause instability to other nuclei present in the atmosphere, and those nuclei become radioactive. So why atomic bomb will lead to gamma emission? I talked about in the last class that why so many children were born with deformity in Hiroshima and Nagasaki, even after 10 years after, 20 years after 1945 nuclear detonation. The reason is that when uncontrolled nuclear fission will happen, it is going to produce lot of neutrons, lot of many other subatomic particles at very high energy. And those subatomic particles can find other atoms in the atmosphere, in the vicinity, and they can make them radioactive. And once they are radioactive, they will emit alpha, beta, or gamma. And that gamma radiation is going to cause genetic deformity, even to a child who has not even born yet. So this is how beta and gamma emission is directly linked to nuclear detonations. So nuclear detonations are not just, of course, they are weapons of mass destruction, that they immediately, in a very short span of time, they will kill thousands of people. And at the same time, they will also cause much, much more problem later. And that is why I do not appreciate a question here that do not talk about nuclear detonation as some sort of joke. That Pakistan is small, what if someday India drops a hydrogen bomb on Pakistan? What will lead to some kind of effect on India? So why would India do that? India is a responsible nuclear nation. India is only going to retaliate. India will never attack with a nuclear weapon. And that is what should be done, right? So yes, if you do feel that there is an imminent threat of nuclear attack, yes, India can retaliate. But saying that India randomly drops a nuclear bomb on some nation, we are not going to do that. If gold is hidden, then can gamma ray detect that? I think you are asking this question because जो हमारा custom department है, वो आपने देखा custom department को Twitter पे आप follow करते हो? I follow them on Twitter. I follow them on Twitter just to look at where people hide the gold. And, and I always get amazed at who thinks of that. But I get even more amazed when custom departments find the location. That ये साबुन के बीच में कहीं पे साबुन है उसके बीच में कहीं पे gold पड़ा हुआ है, like things like that. So yes, not exactly gold, but presence of metals can be found using many scanning. There are many scanning devices which can find presence of metals even deep inside some solid surface. And so they will not tell you exactly it is gold, but yes, it can tell you presence of metals. And then of course, you can inspect that and you can figure out if it is gold or something else. Gamma scanning uses in archaeological excavation. We can do that. Archaeological excavation में gamma scanning हम use करते हैं, because जो gamma scanning है that allows, जैसे मान लो whenever archaeological excavation happens, that there was some civilization, but because of deposition of wind or many other things, now it is buried into layers. So below that layer, do we find a hollow ground which may contain, let's say for example, traces of a civilization? So yes, for that we can use gamma scanning. In Oppenheimer movie, he talks about once chain reaction starts, it will never stop. Okay, yeah, that is actually there. So when Manhattan Project was going on in America, Oppenheimer, last year there was a movie, Oppenheimer also, in fact, it received best picture Oscar jury award. So in Oppenheimer movie, that actually is historically correct. That one of the fear the scientists had, that there is a very low probability, almost 1 by 1 billion or 1 trillion, but there was a probability that this chain reaction will never stop. It will produce so much of energy that this chain reaction will go on and it will engulf the entire world. And then Oppenheimer goes on to Einstein to ask about this, that do you think it is possible? What according to you should we do? So yes, there was a not non-zero probability. It was very close to zero, but there was a non-zero probability. Now we know that that did not happen, thankfully. And it does not happen because of nuclear detonations. I will give you some time to answer this question. This was asked by UPSC, 15 marks to 50 words. आप लोग ये मरमर बहुत करते हो. Don't do that. मेरे से क्वेश्चन पूछो, क्लास के बाद बातें करो. And you're right, even radars can be used for archaeological excavation. There is a question. Radio waves also have this property that they can cross solid objects. Yes, go ahead. Anyone who can, yes, go ahead. आप आपसे एक सेकेंड. हाँ जी, बताइए, आप बोल रहे थे. Gas cooled reactors we do not, we are only doing at experimental stages. Like they are only, we are only experimenting with them. We do not have gas cooled reactors per se. I want some other people. Yes, you were saying something. Just a second. हाँ, बता रहे थे कुछ. Be louder. Again, I do not want the complete answer. I do not want sentence by sentence formation. I just want the main bullet points. You do the elaboration at your home. I just want the main bullet points which you are going to elaborate in your answer. Okay. Very good approach. Uh, I have just one suggestion. In the first part, do not limit yourself only to nuclear reactor. Question was not at all talking about just limiting yourself to nuclear reactor. Yes, go ahead. Okay, that's a very good point. That's a very good starting. कल्पकम तो चलो फिर भी फास्ट ब्रीडर रिएक्टर है, बट बिफोर दैट वी कैन टॉक अबाउट तारापुर और अप्सरा, ये सारे हम डिस्कस कर सकते हैं. यस. ओके. ओके. I really appreciate the way you have formed your points. So I will give you a few examples what he had said. So he talked about that how Indian Council of Agricultural Research is doing mutation breeding to develop new varieties. Then he talked about that how Department of Oncology at AIMS is doing cutting edge research for cancer treatment using nuclear technology, right? And believe me, even if they are doing it, so you do not have to be, ऐसा नहीं है कि आपको ये अगर एम्स ले लो या टाटा जो है कैंसर रिसर्च इंस्टीट्यूट है बॉम्बे में, और अपोलो जो चेन्नई में है, these are like top most institutes which are doing cutting edge research in cancer treatment. So that's the way you have formed. I really like that. Yes, go ahead. Yeah, yeah. Okay, that's a good point. Somebody, yes, go ahead. Applications of, हम बिल्कुल लिख सकते हैं, क्यों नहीं लिखेंगे हम. जैसे आप एग्जाम्पल बताओ क्या आप लिखना चाह रहे हैं यहाँ पे. हम बिल्कुल लिखेंगे. तो जो फर्स्ट पार्ट है, द पॉइंट आई मेंशन्ड अर्लियर, that in the first part don't limit your answer only and only to energy production, because question is not limiting itself only to energy production. In second part, yes, that will be very specific to nuclear reactor. You will briefly talk about three-stage program and the significance of fast breeder reactor. But in first part, talk about, and the best type of answer will here be that if you do have some historical evolution of things. जैसे we established Atomic Energy Commission just after independence. The first reactor Apsara under leadership of Dr. Bhabha in 1956. Three-stage program again envisaged by Dr. Homi Jahangir Bhabha to effectively utilize thorium reserve into India. Pokhran 2, 1974, when Indira Gandhi was Prime Minister. We can talk about that. We can also mention some of the reactors, which earlier reactors at Tarapur, which we had a lot of help from Russia in that particular case. In some other cases from America also. We can talk about that. You can also jump to when India declared it to the world in 1998 that we do have a nuclear weapon at our arsenal, at our disposal. We can talk about that. You can also talk about the Indo-US nuclear agreement, which happened in 2008 when Dr. Manmohan Singh was Prime Minister. You can briefly mention what Department of Atomic Energy is doing, not just limited to energy production, but in other areas also like mutation breeding, or how many hospitals are using nuclear technology for cancer treatment, or nuclear medicine is helping in disease diagnosis. So do not limit yourself, your answer only to energy production, focus on the other aspects also. And then go to the second part. In second part, you will give a brief introduction about three-stage program. That fast breeder reactor is the second stage in this three-stage program, where we do not use a moderator. We use fast neutrons. You'll explain that these fast neutrons may not be very good at fission, but they're really good at converting thorium into uranium. And then and there you can also write the reason we are calling it fast breeder, because it breeds more uranium than fission of plutonium. एंड यू कैन ब्रीफली, अभी चूंकि आज मैंने अभी क्वेश्चन दिया है तो आप अभी जो रिसेंट अभी डेवलपमेंट है आप उसके बारे में लिख भी सकते हो. दैट इंडिया हैज स्टार्टेड फ्यूल लोडिंग एट कल्पकम, जो पहला हमारा फास्ट ब्रीडर रिएक्टर है सिचुएटेड इन तमिलनाडु. सो वेरी इंपॉर्टेंट टू रियलाइज द पोटेंशियल ऑफ thorium reserve in India we do have. We can talk about fast breeder reactor. So that is how you can complete your answer. Write this answer at home. This can be today's homework. I will also show you few prelims questions, some objective questions. Acha, some students, online students have highlighted that how we can also talk about tokamak, Aditya tokamak SST1, or we can also talk about that how India is part of ITR, International Thermonuclear Experimental Reactor. So those things can also be written in this particular question. Yes. फ्यूल का साइकिल इस सेंस में इंप्रूव हो जाता है कि हम थोरियम से यूरेनियम रिकवर कर सकते हैं. इस तरीके से फ्यूल साइकिल इंप्रूव होगा दैट वी कैन रिकवर यूरेनियम. Thorium, as thorium transmutates into uranium, we can recover from that. Look at this question. क्या होगा आंसर? ये तो फिर भी इजी है यहाँ पे, जिस तरीके से ऑप्शंस अरेंज्ड हुआ है. आई नो दैट आउट ऑफ 4 1 इज नॉट करेक्ट, राइट? सो आंसर इज डी हियर. थर्ड इज नॉट करेक्ट. इट यूजेज अ fission chain reaction to generate energy. Not at all. It uses alpha decay to generate energy. But first is true. Source of both heat and electric energy for space missions. Second, launching missions deeper into space. That is also true. And fourth is also true. Plutonium-238 is used to provide heat and electricity in RTG. 1, 2, and 4 answer is D here. Same question in the current pattern will be, how many of the above statements are correct? 1 only, 2 only, 3 only, all 4. Answer will be 3 only. One of the statement is not correct. This question. This is also easy. To use thorium reserves and convert into good fissile material. So first, yes, we are doing that, but in the first stage, in pressurized heavy water reactor. Second, not at all. Third, that's a made up statement. Fourth is the correct answer. Look at this question. क्या होगा आंसर 3 का? The energy released in fusion reaction is greater than energy released in fission reaction. So for same amount of fuel, that is a correct statement. Fusion does not normally occur in nature. Fission occurs in stars. Exact opposite is true. Fission generally does not occur in nature. Fusion occurs in stars. So second is not true. At present, nuclear fission reaction is used in nuclear power plant. Fusion is still in experimental stages for producing power. That is true even with the news which I talked in the last class, that there has been a net energy gain at Lawrence Lab, California. Even with that news, third statement is true. Because what has happened has occurred on a very smaller scale. Our goal here is to scale it up to produce power for, let's say, entire city. So third statement, that is true. Answer is 1 and 3. D is the correct answer. What about this one? उसके नेगेटिव मार्क्स मिलते हैं. If you mark both A and B, you get negative marks for that. उससे अच्छा मार्क मत करो. You always have the option to not attempt questions. Always remember that. You do not have to go and attempt all 100 questions. Last year UPSC का cutoff था 76, 75.23 something like that. So you answer 38 questions out of 100 and you clear prelims examination. Just 38 and you clear prelims examination. Of course, you do not know beforehand what will be the cutoff, so you cannot take that risk. But the point here is that you do not have to attempt all the questions. Some questions you can leave also, particularly जो factual questions हैं, and you are not very clear about the facts. So if you have eliminated 2 options, then चलो फिर भी ठीक है, हम attempt सोच सकते हैं करना है नहीं करना है. But if you do not know anything and आपने random तुक्का मारा है, there is a chance that it will get correct. There is a 25% chance that it will get correct, right? The problem here is that you feel good about that. Don't feel good about it. That will lead to a slippery slope, because you'll have this habit of then attempting taking unnecessary risk, random risk, which will not be very much rewarding in the examination. So because you'll realize in longer run, as you attempt more and more papers, you'll realize that such type of unnecessary risk, they are much more going to cause problem rather than going to give you a reward. Human brain often seeks for rewards, and whenever rewards अगर मिलेंगे तो वो जो impact हो बहुत ज़्यादा amplify होगा. So you remember the rewards, but you forget about the losses which you suffered. And that is why when you take some random tukka, some of the answers you'll get correct, you'll remember that कि मेरा तो तुक्का सही हो गया था. So ये जो है, this is not a good strategy. If you are not very sure about a particular question, and especially if you do not know anything about that particular question, don't even think about attempting. If you know something, you have eliminated one statement, you still are left with 3, don't attempt then also. If you have eliminated 2 options, now it is 50-50. There is a probability of that you get 50% probability to be correct, 50% probability to be wrong. Now, as per law of probability, if let's say there are 10 questions like that, in 5 questions you get correct, 5 questions you get wrong, you are still in net positive, right? जो कट ऑफ है, जो नेगेटिव मार्क्स है वो -1/3 है. So if you got 5 correct, 5 incorrect, there are 10 questions where you had this 50-50 scenario, and out of that 10 question, I'm saying that 5 you get correct, 5 you got incorrect, and you still are in net positive. There are people who will give you this strategy also. But the problem with this strategy here is that probability works if your sample size is really large. What do I mean by that? I toss a coin, the probability of getting head or tail is half or half. But there is a chance I toss that coin 10 times and I get 7 head and only 3 tail. Virat Kohli, jab captain tha India mein, always used to lose toss. So, not his fault. So anyways, the point is that when you toss a coin 10 times, there is a probability of getting 7 head. Yes, it is possible. But when you toss it 100 times, then you will get 45 head, 55 tail. You do that 1000 times. So as your sample size increases, the probability of half actually, it converges to half as you have more and more sample size. So when I made a statement that in 10 questions you had this 50-50% scenario, I assumed that you'll get 5 of that correct. That is not a good assumption. There is a chance that you'll get 8 of that incorrect, or even 10 of that incorrect, and only 1 or 2 correct. So be very careful even in those 50-50 questions. That you'll decide then and there, depending upon the risk appetite you have, depending upon the other questions you have attempted in the examination. And it also should depend upon the aptitude in that particular question. That question मान लो geography का, geography में आपका aptitude better है. That it is not 50-50. You have some understanding, and because of that, one of the option you think that has better chances of getting it correct, and you mark that option. But that aptitude only improves when you spend a lot of time studying a particular subject. जैसे in this question, I don't think it is 50-50. Third is wrong. We know that third is wrong. जो fast breeder reactor है, that will be at Kalpakam. I eliminate third. I know that first is true. 1 and 2 only. I know first is true. I have to know about second. Now I told you that in 3-stage program, most of our reactors are, first stage reactor should be pressurized heavy water reactor. So a reactor being a pressurized heavy water reactor, there is a very, very high probability for that. But a reactor being pressurized water reactor, there is a very low probability for that. So if I do not know this, then I would think that 2 should be true. Agar same question 1 and 2 only hota, then that would have been a more difficult question. Because I had to precisely know then that pressurized water reactor जो है वो कूदन कुलम पे जो कि है, and second भी true है, यहाँ पे answer B है, 1 and 2 only है. Just in case I have mailed this slide. These are the active nuclear reactors in India. ये ज्योग्राफी के पर्सपेक्टिव से भी आप याद रखो, नॉर्थ टू साउथ, ईस्ट टू वेस्ट आप अरेंज करके देख लो, पहली चीज तो ये. एंड सेकेंड थिंग, out of all these reactors, so these are the stations, at one place there can be 2 or 3 reactors. Remember that we have about 20 active reactors, which simply means that, let's say for example at Kakrapur you have 2 or 3 active reactors. So you have all these places, you have nuclear reactors, and you have at Tarapur you have a boiling water reactor, only one place where we have boiling water reactor. At Kudankulam in Tamil Nadu we have pressurized water reactor, and बाकी जितने भी reactors हैं, all of them are example of pressurized heavy water reactor. So we can remember this also, that only you just have to remember these 2 places. Tarapur boiling water reactor, Kudankulam pressurized water reactor. Rest all the places are pressurized heavy water reactor, which is part of our first stage nuclear program. तो इस तरीके से भी हम चीज़ों को याद रख सकते हैं, ठीक है. सॉरी, कल्पकम हम यहाँ पे ऐड करेंगे. कल्पकम अभी एक्टिव हुआ नहीं है, अभी तो बस हमने फ्यूल लोड करना शुरू करा है. We have just started loading the fuel, so it has not become active per se. But once it starts producing energy, yes, we will be adding Kalpakam also. But Kalpakam will be a fast breeder reactor. If I have to add here, Kalpakam will be a fast breeder reactor. There is one more recent development which I should briefly tell you before I go to the next topic, nanotechnology. There is a talk of small modular reactor. I'm not going to make you write anything. I'll just briefly talk about what is this small modular reactor. China, Russia, US, these 3 countries, they are quite bullish on small modular reactor. And I remember 2 years ago, one of the scientists of Niti Aayog, he talked about that even India should pursue its effort towards small modular reactor. So what is a small modular reactor? As the name suggests, first it is small. Small का मतलब यहाँ पे ये है that it is going to occupy less space first. It literally is small, that it will occupy less space. It will also have less energy producing capacity. So typical nuclear reactor, which I talked about at Tarapur or at Kakrapur, all of these reactors, they often will have capacity in the range of 700, 800 megawatt. A small modular reactor will have capacity in the range of 200, 300 megawatt. 300 is the maximum value. That is the first thing, that we are not talking about huge capacity. We are talking about capacity in the range of 100, 200, 300 megawatt. Hence the word small, and it literally occupies less space here. First thing. Second word here is modular. Modular word का देखो क्या मतलब होता है. Modular word we use in real estate for kitchen. Modular kitchen सुना आपने एक term? ब्रोकर के पास जाओगे, ब्रोकर बोलेगा इस घर में मॉड्यूलर किचन है. What does that mean? What does that word modular kitchen mean? Arranged. Exactly. There is a kitchen somewhere. वो आपके घर पे आके लगा दिया. So एक बना बनाया किचन है, कोई कंपनी है, उन्होंने अपना बना सा एक किचन का मॉडल तैयार कर रखा है. They looked at the dimension of your kitchen, and based on that model, they will construct everything, and they will just come and install each and every part of the kitchen. So you have a simple roadmap is there, or simple diagram is there, and based on that, something is constructed somewhere else and installed in your kitchen. Nuclear reactor, modular reactor is also like that. So one of the biggest challenge in nuclear reactor is that you need a very large piece of land. So you need to acquire land. I already told you there is a lot of opposition to nuclear power in India. So land acquisition becomes difficult. There will be some NGO, local NGO, will collaborate with people. That protest will go on for very long. So land acquisition, that will become a case in court. First it will go to High Court, it will go to Supreme Court. All of that can take not months, it can take years. And the company which thought about that, okay, this much money I'm going to invest in nuclear power, the more a project delays, they are going to lose more and more money. So this is a problem, that you need to acquire a large piece of land. And once acquisition is complete, you start construction, which will again go on for few years. You start loading fuel, start producing power. all of that leads to lot of time and lot of money. And before the time you become break even का मतलब ये है that whatever money you spent, finally you have recovered all of that money back because of your business. So think of this as a business proposal that you spent 100 rupees across 4-5 years, and then it is going to take another 4-5 years to recover that 100 rupee back. After that, you will come into profit. So nuclear reactor is very expensive. It is a time-taking process. There is a high capital cost requirement. To overcome this issue, lot of countries, particularly Russia here is leader, and Russian design is becoming popular in China also, but even US has started working towards this type of reactor. We call them small modular reactor. That these are small reactors, they do not need a large patch of land, first. Second, some of the major components of the reactor can be built somewhere else, and when land acquisition is complete, we can simply install that part once the land acquisition is complete. So जो time है और जो cost है, that we get to reduce. And third, जो अभी small modular reactor के designs हैं, they are like this, that once you load the fuel, you do not need to refuel it for 5, 6, 7 years. In case of typical reactor, it was 2 to 3 years. I told you that once you load the fuel in a typical large nuclear reactor, you do not need to refuel it for next 2-3 years. In modular reactor, the same time is 4, 5, 6, 7 years. You do not need to refuel it for 4, 5, 6, 7 years. Yes, the energy produced will be less, but because they occupy less land, we can have more number of them. We can have small modular reactors at many of the locations, and we can produce more and more energy from that. So this is a design which many countries are already investing a lot of resources into. Some prototype small modular reactors already are active in Russia, US, and China. And even India is talking about it. India hasn't, I will repeat, India hasn't started anything in this regard. We just have a proposal on a piece of paper that India should look into type of reactor called small modular reactor. Let's take a break here. After that, I'm going to discuss the next topic, a small topic. I will try to complete as much as possible in today's class itself, nanotechnology. There was an interesting question asked earlier. How do we know about what is inside the sun, or which reaction exactly is happening inside? Now that's a good question. How do we know about the internal layers of sun, or what type of reaction is happening inside sun? We have asked this question a lot, that how do we increase our knowledge? How do we enhance our knowledge about the working of nature? And one of the most important contribution is that when we started accepting human limitations, when we started accepting that with the help of our sensory organisms, with the help of our eyes or ears or skin, yes, we can gather a lot of information, but the sensory organisms have a lot of limitations. A lot of things occur in this nature in a realm which we cannot perceive only and only because of our sensory organisms. But the good thing about human brain is that we can think in abstractness also. So how do we know about internal layers of sun? First, we do a theoretical calculation. But that theoretical calculation depends upon the already confirmed data which we receive from sun. For example, we can estimate the size of sun compared to Earth. Then we can know about the temperature of the sun, the surface, the photosphere ka temperature hai. There are many ways to do that. We can estimate the temperature. For an object so huge, that entire surface is at temperature of 6000 degrees Celsius. It must have some source of energy, that should be very clear. And that source of energy clearly is emanating from inside of it, that is also very clear. So that is how we go step by step. Then we calculate the amount of neutrino sun is emitting. By the way, sun does emit neutrino. And the amount of neutrino sun is emitting, let's say Earth receives a fraction of it. Compared to what fraction of neutrino Earth receives, what is the total neutrino sun produces? What are the reactions which produce neutrino? So all of that, we start with what already we know. Then we try to fit that into a theoretical model. And then we simulate all of that with the help of very powerful computers. And then we see that what this model is telling us. And this model will predict few things. Are those predictions true? Let's confirm that. Are those predictions not true? Change the model. And then again, let's confirm what the new predictions are. So step by step, we increase our knowledge based on first theoretical calculation, and we confirm that theoretical calculation with the data input we receive from sun. So that is how we know about so many different things. तो sun तो चलो फिर भी solar system का सबसे essential part है. But in the previous class, I told you that how scientists are wondering that there is a planet few hundred light years away from Earth, and that planet may have life on it. And there was a recent, so one of the leading scientists, an Indian origin scientist who is working on this project, there was an interview published, his interview published on YouTube. And the interviewer told him that you are going to become the most famous person in the world. And yes, he will be. Because his team, he is leading a team which is investigating into the data collected by James Webb Space Telescope, which can perhaps tell us that there is life on some other planet, just by collecting the light which Webb Telescope has received. Kalpakam will be the only nuclear plant with 3-staged nuclear program. Why would you think that? ये मैंने कब बोला? 3-staged program ऐसा थोड़े है कि एक ही न्यूक्लियर रिएक्टर पे पहले हम PHWR बनाएंगे, फिर हम उसी को हम FBR में कन्वर्ट कर देंगे. ऐसा we will not do that. We will have pressurized heavy water reactor here and there, and in processing facilities we will recover plutonium, and then we will use that plutonium to load at Kalpakam. So Kalpakam is our first fast breeder reactor. Maybe once Kalpakam becomes successful, we will have more such fast breeder reactors. And with the help of many such fast breeder reactors, we will enter into the third stage, where we will start using thorium on a much larger scale. So all of our pressurized heavy water reactors, they are part of 3-staged. But जो pressurized heavy water reactors हैं, they belong to the first stage of reactors. जो Kalpakam Tamil Nadu है, that belongs to second stage of reactor. And after that, we will enter into third stage of reactor. Give the heading nanotechnology. So in the previous topic, we talked about nuclear technology. We looked at dimension of femtometers, 10 to the power minus 15 meter. We are going to zoom out a little bit, not a little bit, we are going to zoom out by a huge amount. And we will go to a scale called nanoscale. So when I use the word nanotechnology, I'm essentially talking about the science and technology and engineering which is happening at the scale of 1 to 100 nanometer. 1 nanometer is 10 to the power minus 9 meter. ये हमको याद रखना है. Now 10 to the power minus 9 is huge compared to 10 to the power minus 15. 10 lakh times bigger than 10 to the power minus 15. So that is why I said that we are going to zoom out a little bit. And we will now look at the nanoscale. In the previous module, I talked about that how atomic scale is in the dimension of 10 to the power minus 10 meter. Now 10 to the power minus 10 is 1 by 10 nanometer. So atoms exist in dimension of 1 by 10 or few angstroms, or they can also enter into nanometer domain. So when we look at assembly of atoms, when we look at materials which are of nano size dimension, and those materials, how do they function? How can we use them in our day-to-day life or in some other branches of technology? That is what nanotechnology is all about. So when I use the word nanotechnology, the definition part is very simple. We are talking about making of nanomaterials. Now what are nanomaterials? Nanomaterials are those materials whose dimension exists in 1 to 100 nanometer. Again, neither we can imagine 1 nanometer nor can we imagine 100 nanometer. Our imagination stops at about 10 to the power minus 4 meter. Below that, we cannot imagine things. To give you perspective, think of the A4 sheet on which you are writing. That is about 1 by 10 millimeter. Now 1 by 10 millimeter is 10 to the power minus 4 meter, right? 1 millimeter is 10 to the power minus 3. So 1 by 10 millimeter is 10 to the power minus 4 meter. And I divide this further 1 lakh times, 10 to the power 5 times, and then I go at a nanoscale. So think of now a nano layer of material. Just say, I will give you the best example of nanotechnology which we are using is in our mobile phone. That हमारे mobile phone का ये जो top layer है यहाँ पे, that top layer, which by the way has become scratch proof, that I use this, there will be no scratch here. A lot of you are wearing glasses, and those glasses have property of anti-fog or anti-dust. All of that is possible because on your glasses there is a very small thin layer, and thin का मतलब nano है, that there is a thin nano layer on your glasses which gives properties like anti-fog property or anti-dust repellent property, all of those things. So nanotechnology is science, engineering and technology which is conducted at few nanometer of scale, often from 1 nanometer to 100 nanometer. But what it is about that 1 to 100 nanometer, that we are studying this as an entirely separate topic. Now that is, I will start this topic with, that what is unique at the nanoscale? What is happening at the nanoscale that we are so much interested in it? This is one of the most important branches of technology in modern world. Goes without saying that when we are talking about changes happening at nanoscale, then we are talking about changes happening within few atoms and molecules. Think about one drop of water which you can see with your naked eyes. In that one drop of water, how many water molecules will be there? Again, trillions to trillions. There will be trillions to trillions of water molecules there. But now think about a nanomaterial of dimension of, imagine some sort of, again a spherical nanomaterial, again we cannot imagine it, but imagine a nanomaterial, a dot, but this dot also has a dimension. This dot has a dimension of 10 to the power minus 4 meter or 10 to the power minus 3 meter. I am talking about a dot, a spherical material, which has, let's say, radius of a sphere, which has a radius of, let's say, 10 nanometer. Compared to water drop. Water drop has a dimension of not 10 nanometer, let's say it has a dimension of 1 millimeter or even 1 by 10 millimeter. In 1 by 10 millimeter of water drop, there will be trillions of water molecules, trillions to trillions of water molecules. But in 10 nanometer of a material, there will be few hundreds to few thousands of atoms. So ये जो जब भी हम bulk scale पे जब भी हम number discuss करते हैं, number of atoms and molecules, that immediately comes into trillions to trillions. And as we go shorter and shorter, the number of atoms and molecules keep on reducing. At nanoscale, that number can be 10 or 100. So think about it. I'm essentially talking about a material which is made of 10 atoms, which is made of 100 atoms, which is made of 1,000 atoms, not more than that, few thousand atoms, not more than that. So I'm not talking about material with trillions to trillions of atoms and molecules. I'm talking about a material made of 10 atom, 100 atom, 1,000 atom, few thousand atom, that's it. Turns out that when we make material like this, and by the way, we can make material like this, but when we make material like this, then that material starts exhibiting unique set of properties. The same properties which you do not see or witness at the macro scale, at scale which you can actually look at things. But when you go at micro scale, when you go at nano scale, the properties start changing. Physical properties start changing, chemical properties start changing, even in some cases biological properties start changing. And then it allows you to enhance material properties. It allows you to have new material properties, properties which not even have existed in the nature before. So nanotechnology allows you to do manipulation at atomic and molecular level, and that manipulation essentially will change properties of materials, and that property can be desirable for us. So ये सबको clear होना चाहिए that जो atomic and molecular arrangements हैं, they essentially decide the property at the bulk scale. And the best example I have for you is, think of two allotropes of carbon. Two allotropes of carbon we have studied in our class 9th, 10th chemistry. One is called graphite, another is called diamond. Both graphite and diamond, they are made of carbon, nothing else. They both are carbon. But one of the arrangement of carbon leads to diamond, a material which is very shiny, very expensive, a material which is so strong that it cannot be cut with anything else except diamond itself. But the other set of arrangement of carbon atoms leads to graphite, which is so soft that when you use it on a piece of paper, it traces. आप उसको piece of paper पे trace कर सकते हो. Use it as a pencil. I can break that graphite with a simple twitch with the help of my hand. I cannot even imagine doing that in case of a diamond. Forget about this twitch. I have very powerful hammer. Even then, I cannot break that diamond. So कार्बन एटम ही है, एटम सेम है, बट जो अरेंजमेंट है, अरेंजमेंट अलग अलग हो गया. इफ यू हैव स्टडीड अगेन chemistry in class 11th 12th, you do know that it has something to do with how atomic arrangement exactly changes and how that arrangement changes the behavior of graphite, two allotropes of carbon, graphite and diamond. So the point I'm trying to make here is that whatever properties which we witness at the bulk scale, those properties essentially are because of how atoms and molecules are arranged at fundamental level, how they are coming together, forming bonds with each other, and how that bond essentially leads to a bulk material. But now I'm not talking about a bulk material. I'm talking about a bond which does not exist between trillions to trillions of atoms. I'm talking about a bond which exists between 10 atoms, 100 atoms, 1000 atoms. Now think of a particle like electron. An electron is a very small particle. For an electron, a bulk material, जैसे मान लो I have 1 gram of gold. Gold is a metal, very good conductor of electricity. Inside gold, electron has a lot of place where it can move around, roam around. But even that 1 gram of gold is like entire universe for that electron. The same way we may feel very small in this entire universe. If electron was a conscious entity, then that electron will also feel very small even in that 1 gram of electron. It is such a small object. Electron ka jo, if I can imagine electron as a particle, by the way, it may not be a particle, but if I can imagine electron as a particle, then it is so small that even 1 gram of gold is like entire universe for us. So electron can roam around anywhere in this gold lattice. But now I convert that macro gold into a nano gold, a gold which is of, let's say, 10 nanometer. And suddenly electron feels restricted. It cannot move anywhere. There are a lot of restrictions on its movement. And that fundamentally alters the property. I will start with giving the example of gold itself. This is what gold looks like in our day-to-day life, right? It has this lustrous, shiny yellow color. Gold is, even though it is metal, it does not corrode very easily. Gold can maintain its purity for hundreds and thousands of years, and that is why few thousand years ago some emperor used some gold coin, and we can recover that gold even today with almost same purity. So gold is not chemically reactive. Gold does not corrode corrosion is a chemical reaction. Gold does not corrode very easily. Gold is not that chemically reactive. It is a metal though, it is a very good conductor of electricity. It has this shiny, lustrous yellow color. This much we know about gold. In these 2 vials, nano gold is kept. Nano gold is kept into a transparent solution. A transparent liquid is used, and in that transparent liquid, nano gold is kept. And one of the nano gold is of 20 nanometer, another is of 100 nanometer. Now, 2 things you will witness. First thing you will witness that both of them are not yellow. And second thing you will witness that this 20 nanometer gold is exhibiting some other color, and that 100 nanometer gold is exhibiting some other color, right? Maybe girls will know the difference. So, but, sorry. But the point here is that gold exhibits different color. At nanoscale, a 1 nanometer gold exhibits unique set of properties compared to 10 nanometer gold compared to 100 nanometer gold. So at nanoscale, material properties start changing. That is the first thing. And second thing, that this change in itself is a function of size. That this change occurs even when I change the size. I have the same material, I have the same set of atoms and molecules. I just change the dimension, the shape and size, and the material properties start changing. Jaise, this pen, I have this pen here. A lot of things I can talk about this pen, even though I have no material in front of, no chemical analysis in front of me. It has, of course, this physical property, which is color. It has this dark gray or light black color. It is made of some sort of polymer, some sort of plastic perhaps. I do know that it is not a good conductor of electricity. I do not have to conduct an experiment for that. I also know that it is not a good conductor of heat. I know all of this property just by looking at it, just by feeling this material. Let's divide this pen into two parts, or let's divide this pen into 2000 parts for that matter. All of those properties which I described about this pen is not going to change. It will still have that dark gray color. It will still be not a very good conductor of electricity. It still will not be a very good conductor of heat. It will still not have very high chemical reactivity, even if I divide this into 2000 equal parts. But my contention here is that if I divide this into 2 billion parts, this pen, and then I will not be able to make all the same claims. I will not be able to make this claim that maybe this is not chemically reactive, or maybe this is not electrically, not a very good electric conductor. I will not be able to make the same claim. For that, I will have to now do experiments. And then I divide this into 3 billion parts, and then my claim will further change. So at nanoscale, properties of materials change. The physical property, the chemical property. Nanomaterials often become highly chemically reactive. There's a nano gold. Gold is not chemically reactive, but nano gold is so chemically reactive that scientists are exploring use of nano gold to destroy tumor, that it has capacity to destroy tumor, a cancerous tumor, and it is actually being investigated as one of the potent tool for cancer treatment. Nano layer, it's so amazing, which I talked about, that this mobile phone has a nano layer, and it makes it, it can resist some sort of scratch here. And by the way, there are so many things which occur in nature also. In nature, you can see nanomaterial. Butterfly के जो beautiful colors of flaps हैं, that beautiful color of its wings, it essentially is because of nano layer of some material. But just if this nano layer changes, there is a nano layer of, let's say, 4 nanometer, same material, nano layer of 6 nanometer, and just by changing the size, it will start reflecting different color. So right now this butterfly is of blue color, but I'm very sure you have seen yellow butterfly also, red butterfly also. So you have seen all of these different colors butterflies, and it essentially is because of a very thin nano layer on their wings, which reflects different light. In this case, the layer of a material, the size of this layer is determining that what light will be reflected the most, a physical property. Lotus, that is a lotus petal. Lotus petal often blooms into wetlands where you have a lot of water. In that wetland, you have a lot of microbial organisms. Microbial organisms, they grow a lot if in water, particularly jahan pe bhi moisture ho, sunlight ho. So lotus blooms in wetlands. But lotus ka jo top hai, at this top again there is a very thin nano layer. And this thin nano layer has this very interesting property that it is extremely hydrophobic. Hydrophobic ka matlab hota hai which does not like water. It repels water. I can categorize substances into 2 groups, hydrophilic or hydrophobic. Hydrophilic means materials which attract water. Hydrophobic means materials which repel water. So lotus ka ye jo nano layer hai, that is extremely hydrophobic. It does not allow water to stay. It immediately repels that water. Now think about if we can replicate the same thing in car windshields, then wiper ki koi zarat nahi hai. Rainfall is happening all the time, that car windshield is repelling water. We do not need water. We do not need that wiper on car windshield. So materials property changes, and we aim to manipulate, or we aim to utilize that property in various domains. And that is what I'm going to discuss about. This topic is very simple, very straightforward. I will divide this into 3-4 parts. What is it? What is nanotechnology? What is unique about nanotechnology? That is the first part. The second part will be applications, and third part will be what are some of the challenges, issues, and finally I will talk about what is India doing in this field of nanotechnology. That's it. So it's a very simple, straightforward topic. Write down a few things here. Give this heading nanotechnology. Nanotechnology is science, engineering and technology. Science, engineering and technology. Technology conducted at the nanoscale. Conducted at the nanoscale. ब्रैकेट में लिख लेना 1 to 100 नैनोमीटर. 1 to 100 nanometer. Materials at nanoscale. Materials at nanoscale. Nanoscale exhibit amazing properties. Materials at nanoscale exhibit amazing properties such as higher strength, lighter weight, greater chemical reactivity, among others, compared to large scale counterparts. Basically it means that I'm comparing same material, जैसे gold को मैंने compare किया, a bulk gold material and a nano gold material. A nano gold will exhibit unique set of properties compared to bulk gold material. One I literally showed you, that color changes. Color is no longer that yellow lustrous color. Color has changed. Other property which changes is that while gold is not very chemically reactive, nano gold is very, very chemically reactive. And it has lot of applications in different areas. And nano gold is just one nanomaterial. There are so many different type of nanomaterials which we are using in our day-to-day life. So give this heading, uniqueness about nanoscale or uniqueness about nanomaterials. Uniqueness about nanomaterials. What changes at nanoscale? Uniqueness about nanomaterials. I should also tell you a brief history here. One of my favorite heroes in physics is Professor Richard Feynman, one of the greatest scientists who has lived. Dr. Feynman, in a very famous lecture in 1959, in this lecture, even though he did not use the word nanotechnology, he described processes at atomic and molecular level. He imagined that human beings will have enough capability, that we will be able to manipulate things at atomic and molecular scale. We'll be able to move atoms and molecules. We'll be able to make materials atoms by atoms, molecules by molecules. And when that happens, this will lead to endless potential, because we can literally alter the properties of material, and we can literally make materials with desirable property. We are not bound by properties of materials which is given by nature to us. We can literally make materials as we require. So he talked about this concept in a very famous lecture, and because of that often people call him father of nanotechnology, even though he did not use this word. This word nanotechnology was coined by a Japanese scientist, Norio Taniguchi, and he used this term for the first time. But nanotechnology only took off with development of a very famous type of microscope. In the last class, previous module, I talked about telescopes. Telescopes look at very distant objects. Microscopes look at very small objects. Typical microscopes, earlier they used again properties of light to magnify things, to look at very smaller things. But now we use electrons also. We use electron for this magnification, and a very specific type of microscope that is called scanning tunneling microscope. The picture which you see, that microscope is called scanning tunneling microscope. Do not worry about the word. What it does, that is more important. What it does is it allows you to look at atoms. That if you are using scanning tunneling microscope, then you can literally see atoms vibrating, moving here and there, molecules. So even at atomic and molecular level, you can look at things, how it is happening. But it also allows you to move atoms. So scanning tunneling microscope does not just allow you to look at the atom, you can literally move atoms as you want inside a lattice. And that led to a lot of development in the field of nanotechnology, because it essentially does involve manipulation at atomic and molecular scale. So nanotechnology has been a domain in making for last few decades, but in last 2 decades particularly, this field has witnessed significant developments. And I'm going to talk about that, what are the various applications we already are using, and what can be even future applications, which right now we are not using, but maybe we will do that in future. But let's start with this first thing, what is unique about nanomaterial. The first is, which I will explain in later classes, but write it down, I want you to write it down. At such scale, at such scale, at such scale, quantum effects rule the behavior of particles, rule the behavior and properties of particles. Quantum effects rule the behavior and properties of particles. Properties become size dependent. Properties become size dependent. Properties become size dependent in this range. In this range. Now, what does this term quantum effect mean here? I'll be talking about this in great detail in the very next topic, information and communication technology. I will briefly mention it here. I will briefly introduce this here. That when you try to explain nature at very smaller scale, Newton talked about movement of planets and stars, and he was more or less right. Here and there, his theories were had limitations, which was rectified by Einstein. But we knew about movement of stars and galaxies and planets before we knew about atoms and molecules. That what is happening at the scale of cosmos, we got to know about that earlier. But when we try to apply the same set of rules and regulations to know about atoms and molecules, turns out that those rules are not valid here. We need to find new set of rules. Turns out nature's behavior at very smaller scale, it becomes quite weird, quite interesting also. And all of those set of rules and behavior, we call that quantum mechanics, a branch of physics. So quantum mechanics is a branch of physics which explains behavior of nature at very, very smaller scale. I'll be talking about this in detail in next topic. So nanomaterials, essentially we are talking about few atoms, few molecules. Hence nanomaterials behavior is guided by quantum mechanics. And at such smaller scale, the properties become size dependent. What does that mean? I was talking about it earlier. 1 nanometer gold, 10 nanometer gold, 50 nanometer gold. All three of them will exhibit 3 sets of properties. All of them are gold, and none of them will be same as the gold which you see in your day-to-day life. So same material, go at nanoscale, properties change, but properties in itself becomes function of size, which means as we increase size or we change the dimension, the properties in itself changes. So that is the first thing. Second thing, write down. Nanoscale materials have far larger surface areas, than similar masses of large scale materials. similar masses of large scale material, a greater amount of material, a greater amount of material can come in contact, a greater amount of material can come in contact with surrounding material, a greater amount of material can come in contact with surrounding material, thus affecting reactivity, thus affecting reactivity. Thus affecting reactivity. Let me explain this further. In the space technology module, one of the online query I remember was that why rockets part, one, these stages separate. When they fall down, they start burning. And why does rocket not burn when it goes up? That was a question. And I tried to answer that with a thought experiment, that imagine a large log of wood, try to burn that and cut that log of wood into smaller pieces and try to burn that. And burning becomes much more easier in the second process. And by the way, burning is a chemical reaction. Let's do one more thought experiment. Imagine a sugar molecule, a large sugar molecule, not the sugar which you find in your kitchen, but a sugar cube, let's say of 1 centimeter sugar cube I have, or 1 meter of sugar cube I have, and I'm trying to dissolve that into water. I have a lot of water, I put that a large sugar cube together. And then the same volume of sugar, but now what we find in our kitchen, same volume, I dissolved into another pan of water, which will dissolve faster. The smaller one will dissolve much more faster. What changed here? That we had same amount of sugar, same volume, but somehow that second sugar, it dissolved much more faster. So this is what surface area is what about. So we can do a mathematical calculation here now. I can do that for cube or for a sphere also. Let's do that for a cube for simplicity. That imagine I have a cube whose side is A, and I divide this cube into 1000 equal cubes. Now इस cube का कुछ अपना surface area, कुछ अपना volume होगा. I want you to tell me that let's calculate this ratio of surface area with volume for this cube. And यहाँ पे जो 1000 equal cubes हैं, उनका कोई एक cube जो होगा, उसका अपना कुछ surface area होगा, and अपना कुछ volume होगा. Let's say that A2 by V2. I want you to do this calculation. I will give you 2 minutes. That if this ratio remains the same, if it increases or decreases, if it increases or decreases, how many times it increases or decreases. So I am giving you a problem here. I will give you 2 minutes to solve this problem. Let me repeat this problem. That I started with a cube with dimension A. A can be anything, 1 centimeter, 1 meter, whatever you want to assume. But I melted all of that cube, kept that into a casket which has 1000 equal sized cubes, divided that into 1000 equal cubes, and then I calculated surface area and volume ratio for that one smaller cube. And my question here is that is this ratio same, or has it increased or decreased? And if it has increased or decreased, by how much? I will give you a few minutes. Not 1000 times. Do this calculation. CSAT में ऐसे क्वेश्चन आते हैं, तो it's a good thing that you are doing this question. CSAT में इस टाइप के क्वेश्चंस आए हैं. By the way, CSAT को lightly तो कोई भी मत लेना, because CSAT का सिर्फ 33% ही आपको लेके आना है. In paper 2 you only have to score 33%. Specifically last year I met so many candidates. I know them to be good candidates, and they did not do well in CSAT paper 2. They failed actually at CSAT paper 2. So उसका problem ये है CSAT paper 2 का अभी, that if you only rely upon, let's say, English comprehension, there will be two problems. There will be a very large paragraph, and from that there will be just one question. So you'll spend a lot of time reading one paragraph, and from that there will be one question or maximum 2 questions, in very rare cases 3 questions. That is the first thing. Second thing, that the options how UPSC arranges, two options will be so close to each other that it will become very difficult to figure out the exact correct answer. If you are having doubts on what I am saying, then pick the last 3-year paper of 2021, 2022 and 2023 CSAT paper 2 and go and solve just the English comprehension part and then match that with official UPSC answer key. And all of you can then check that how well did you do on English comprehension. I'm only and only talking about English comprehension. So only relying upon English comprehension, that's not the right way. You have to solve questions of logical reasoning, questions of mathematics, and questions of mathematics will not be very difficult. They will be from 9th and 10th level. So that is why CSAT paper 2 cannot be taken lightly. So anyone has answer to this question? 10 times, okay. Anyone else? We can do this calculation. So if I divide this larger cube into smaller cubes, one thing which will not change is volume. Nothing can happen to volume. Volume will remain the same. So I know that volume of this cube is a cube. A इसका side है. Volume क्या होगा? A cube होगा. I do not know side of this smaller cube. Let's assume that it is x. But I have 1000 of that. So these two parameters should be equal. That volume of one cube should be equal to volume of this 1000 smaller cubes. And I'm assuming that all of those smaller cubes have side x here. So यहाँ से x I did calculate in the form of a cube by 1000 का हम cube root लेंगे. This will become a by 10. So I know what is x. X in terms of a is a by 10. Now I can do this calculation. A1 by V1. A1 is what? 6a square. Cube has 6 faces. All of the faces are square. Area of square is a square. So I have 6 times a square divided by volume. This becomes 6 by a. And what about A2 by V2? So A2 is 6 into a by 10 into a by 10 divided by a by 10 into a by 10 into this becomes 60 by a. So initially the ratio was 6 by a for that larger cube, but this ratio now has 60 by a. Surface area has increased 10 times. What does that mean? More surfaces are exposed to the surrounding. So why that smaller sugar cube dissolves into water faster? Because as we divide that larger cube into smaller cube, more and more sugar is in contact with water molecule, which will escalate the entire process of dissolving. And same thing also happens in case of chemical reaction. That what I talked about earlier, that I have a larger log of wood, tried to burn it, it is difficult. I divided that wood into very smaller parts and then I try to burn it, it is easier. So surface area increases, you can now absorb more and more heat energy simultaneously, which will increase the burning process, which will escalate the burning process. And that is true for all chemical reactions, that if you have more surfaces exposed to each other, then chemical reaction will occur much more faster compared to if less surface is exposed to each other. So in general, again, it is not an universally true statement. In general, nanomaterials are highly chemically reactive. There are nanomaterials which are not chemically reactive, but most of the nanomaterials, they are highly chemically reactive. This is something which we should know, and that comes from this property of increased surface area at very smaller scale. Third benefit. Most of the biological processes occur at nanoscale. Most of the biological processes occur at nanoscale. For example, a strand of DNA, a strand of DNA has diameter of 2 nanometer. A strand of DNA has diameter of 2 nanometer. Hemoglobin molecule has diameter of 5.5 nanometer. Hemoglobin molecule has diameter of 5.5 nanometer. Now, why is this part important? This is important because of how nanotechnology has applications in healthcare industry, in healthcare sector. Let's say that you are not doing well. If you're not doing well, if you, let's say, for example, have fallen sick, you are suffering from some serious ailment, it's not that your entire body is not working. It is that disease clearly is localized somewhere, some tissues have been damaged, something has been damaged, something is not working well. And often we take medicine which has a general impact. Nanomedicines, so if I can target that diseased tissue at a very specific place, or think about आपका हाथ कट गया है, आपका हाथ कट गया है, आप बॉडी खुद को रिपेयर कर लेगा, राइट? स्टेप बाय स्टेप आपको बस ये इंश्योर करना है that it does not have any infection. You just have to cover it and body is going to repair it. But think about that repair, that how those cells are repairing each other. It is actually happening at nanoscale, that all of those cells, whatever cut, body is trying to repair it, that repair is happening at nanoscale, and after a day or two that repair is complete. So we can have very precise intervention in our body if somewhere some tissue damage has occurred, somewhere some tumor is located, there is a cancerous tumor, I have to precisely destroy that. I can use nanomedicines for it. So nanotechnology has one of the most important set of applications of nanotechnology is in healthcare, that it allows you to make alterations, interventions at the level of cells and tissues, because after all, those cells and tissues also exist at nanoscale. So it allows you to make very precise alteration. जैसे when we talk about gene editing, right? Gene, आपका biotechnology का class हुआ है? In gene, you will be taught in detail about gene editing. Gene editing is a very precise alteration of your DNA. For such precise alteration, you often will require some nano components, some sort of nano component which can lead to that precise changes. So nanotechnology has one of the most important set of applications in the field of medicine. And I'm going to talk about more about that. So these are some of the unique features of nanotechnology we should know about. I will directly jump to the application part, give this heading, applications of nanotechnology. Applications of nanotechnology. And I'm going to divide this application into many parts, 4 parts, mostly 4 parts. I'll be first talking about how we are using nanotechnology in our day-to-day life. Second, I will be talking about how we are using nanotechnology in ICT, in electronics basically. Third, I'm going to talk about how do we use nanotechnology in healthcare. And fourth, I will be talking about how we can use nanotechnology in environmental remediation, in tackling a lot of environmental issues. But I'm only going to talk about 4 of them. But there are no limitations per se. Nanotechnology has applications in defense and space. The rocket ka jo body hai, that is becoming much more stronger and lighter because of nanotechnology. So nanotechnology has applications in any branch where material science has applications. And by the way, I may have talked about this earlier. I will repeat this. Material science is one of the least talked, but one of the most important branch of technology. We do not talk about material science enough in our day-to-day life. We are much more interested in fascinating things like what is happening in astronomy or what is happening at quantum scale. But most important technological development are happening at the level of how we are making new materials. And that is why I may have talked about this, that this mobile phone, we think of the powerful circuitry this mobile phone has, which allows us to store so much huge amount of data, process such a huge amount of data. But it essentially 90% of this is actually material science. That what type of materials I have to use to make all those transistors which make computation possible, and what type of material is required which can make the screen scratch proof or which can increase the look of this mobile phone. All of that essentially is material science. So material science is one of the least talked but one of the most important branches of technology. It has applications in any area you can think of. All the time we are trying to find new type of materials with unique set of properties which can lead to technological progress. So nanotechnology has been one of the most important tool which has further fueled this branch of material science. Nanotechnology allows us to make new type of materials with unique sets of properties. So material science में जो revolution हुआ है पिछले 15-20 साल में, बहुत सारे कारण हैं, but one of the very important reason here is this field of nanotechnology. So I will start with how we are using nanotechnology in our day-to-day life. आप लिख सकते हो, first applications in daily life. Applications in daily life. Applications in daily life. First, glasses and display. Glasses and display. इसमें एक लाइन लिख लेना, nanoscale films. Nanoscale films on eyeglasses. Nanoscale films on eyeglasses. Computer and camera displays. Computer and camera displays can make them residue repellent, anti-fog, scratch resistant among others. Scratch resistant among others. So almost all of our mobile phone displays, camera displays, computer displays, even eyeglasses, they are using a very thin layer, a very thin nano layer, hardly a few nanometer. But even that few nanometer layer plays a very important role, which can introduce many of these properties, or even more than that. I have only mentioned few of them, but even more sort of properties. Another application of nanotechnology is in fabrics, in the clothes we are wearing. A lot of clothes have this property of anti-wrinkling or anti-staining, that उस पे जल्दी से दाग नहीं पड़ेगा, और दाग अगर हो भी जाए तो बहुत जल्दी clean हो जाएगा. And all of that is essentially because some nanoscale additives are added while making this fabric, which can introduce all of this interesting property. In fact, nanoscale additives can also make a fabric resistant to bacteria. And this, I got to know about this very interestingly. So I went to buy a shirt. I'm talking about first lockdown in 2020. COVID seems like a very long ago, but it was hardly like 4 years ago, 3-4 years ago. So in 2020, when first lockdown happened, if you remember watching TV at that point of time, only two type of ads were coming. One type of products which were killing bacteria, another type of products which were boosting your immunity. याद है आपको, हर चीज, everything was boosting your immunity or everything was killing bacteria. So I went to buy a shirt and the salesman tells me कि ये shirt antiviral है. So I was very surprised. I say that how can that be? But I thought that let's search more about it. So shirt can never be antiviral. Viruses always and always require a living host to multiply themselves. They cannot grow on non-living surfaces. And that is why viruses are considered neither living nor non-living, that they need a living host. But once they do occupy a living host, they can hijack the cellular machinery and they can multiply. But we can make shirt antibacterial in a way that bacteria will not have a very good grip on particular type of fabric. And because of that, they will not be able to multiply rapidly. Bacterial infection happens because bacteria find suitable place where they can stay, they can multiply, they have all of the nutritional requirement, and they can multiply rapidly. So we can change the surface property in a way that bacteria will not be able to multiply a lot. So yes, we can make fabrics antibacterial, but not antiviral. So he was onto something. He was not 100% accurate, but he was onto something. So you can write down few things here in fabrics. Fabrics, nanoscale additives, nanoscale additives, nanoscale additives can help in resist wrinkling, can help in resisting wrinkling, staining, and even inhibiting bacterial growth, and even inhibiting bacterial growth, even inhibiting bacterial growth. Some companies are working on something called smart fabric. अब जो smart fabric है, जैसे we are now, lot of wearable devices have become very popular. People wear those watches, those smart watches. जैसे Apple का मान लो smart watch है, किसी के पास है यहाँ पे Apple smart watch? Okay, so Apple smart watch जो है, that has sensors. Those sensors can monitor your bodily movement. It can tell you about oxygen concentration or let's say blood pressure also. And that smartwatch is connected to your mobile phone. You can have all of that data on your mobile phone also. But now some companies are working on clothes, smart fabrics, that those sensors will be part of the fabric, the shirt you are wearing. It will have very small sensors. And as you move, and those sensors do not need as such some separate power source. They can be powered with the movement of your body. As you move, you are producing energy. So they can be powered with the movement of your body, or maybe they can be powered with solar energy also. And they will be able to calculate important data about your bodily functions, about again all of those things, how different functions of your body. So that will also include nanotechnology, that if you have smart fabric, it is going to utilize nanoscale additives. That is another set of applications which is under development. Third, in cosmetics, you have, give this heading, in cosmetics. I'll give you two examples of cosmetics. The first is sunscreen lotion. So sunscreen lotions have been using nanoparticles of titanium dioxide. Now there is a very specific nanoparticle called titanium dioxide and zinc oxide. ये जो दो materials हैं, इनका जो nanoscale particle है, that is being added into sunscreen lotion, and that allows more and more reflection of the sunlight, that your skin will be protected from dangerous UV light or even from much more sunlight. And the second application is lipsticks, that you have a particular type of nanomaterial called liposome or nizosome, which is often used in lipstick so that it can maintain its redness for longer duration. So there are many applications of nanotechnology even in day-to-day life cosmetic products. आप लिख सकते हो sunscreen lotions use nanoparticles of titanium dioxide and zinc oxide to provide protection from sun rays, to provide protection from harmful sun rays. They are also used, not they are, sorry, some nanoparticles are also used. Some nanoparticles are also used in lipsticks, Fourth, household products. Household products. Let me give you again few examples. Lot of cleaning agents. Even in surf detergents, some surf detergents, they have nanoparticles which makes them better at cleaning stains. But in lot of household cleaning products also, like you have cleaning product called degreaser, कि आपके दीवार में grease जैसा substance जमा हो रखा है, and often we use certain type of materials to clean it, and often that will include nanostructured material. तो आप लिख सकते हो in household cleaning products, such as surf detergents, degreasers, stain removers, nanoparticles are added. तो ये तो एक सेट ऑफ एप्लीकेशन हो गया. Give the next heading, applications in electronics and IT. Applications in electronics and IT. Few things we can start with. I already have told you. Write down. Mobile display technology. Sorry, we all have written about that point, right? Let me explain few more things first. How it has applications in electronics and IT. You have come across these days this concept of flexible display. पढ़ा आपने? जैसे Samsung का जो Z Flip phone है, that is an example of bendable display. That you can bend it, but when you again unbend it, you have a larger display here. And many mobile phones, Samsung is doing a lot here. Apple also is entering into this domain. Many other companies are working upon this flexible or bendable display. All of this display is possible because of addition of nanomaterial. First application. Second application is into a type of television you might have seen in some showrooms or perhaps in your houses also. जो typical हम TV use करते हैं, जैसे पुराने TV used to be LCD, things improved in LED. You have OLED, but you have a very particular display called QLED display. किसी ने सुना है पहले QLED display? Go to any TV showroom, Samsung, LG, कहीं पे भी चले जाओ, Sony. Ask them about QLED display, and they will show you this particular type of display technology. So let me briefly also talk about how that display technology functions without going into the nitty-gritties of thing. जो typical LCD LED display है, that uses a backlight. So if you open your TV, at the back of this entire display, you will find a source of white light. And that white light, as it passes through many filters, using many substrates, it can produce these colors. That is how a typical LCD LED works. Typical LCD LED display का कुछ benefit है. It has a longer lifetime, cost उसका कम है. उसका जो सबसे बड़ा shortcoming ये है that display is known for resolution of colors, that how effectively it can resolve between these two colors, how good its white and black is. So LCD LED display will fail at those parameters. Then comes OLED display. OLED display will not have that backlight. It has no backlight there. What it does have, that if you open the front panel of your TV, you'll find very small devices, this much small devices, LED devices, red, blue, green color LED throughout your TV panel. And that red, blue, green LED, why red, blue, green? Because these are three primary colors. And with the help of these three primary colors, I can produce any color. So if red, blue, green, all three of them are illuminating in the same intensity, that will produce white color. But if I change the intensity, if I mix red little less, blue, green little more, I can produce some other color. So I can produce all sort of color with the help of just this 3 color. So the OLED display hai, that does not have this backlight. It does not have that white light source at the back of your panel. Panel in itself has this very small source we call LED light, and it can emit its, when electricity passes through it, it emits its own light, red, blue, green, and depending upon how much red, how much blue, how much green, it can produce all of the colors. इसका जो सबसे बड़ा बेनिफिट ये है कि जो कलर कंट्रास्ट है, this improves very very significantly, and that is why OLED display, you'll find they are very expensive, that they are quite expensive compared to typical LCD LED display. So color contrast improves a lot. High resolution TV, which we talk about, that you can get that in OLED TV. In QLED TV, it is very similar to that LCD LED I talked earlier, but the difference here is that at the front of TV, rather than using those filters, we use a particular nanomaterial called quantum dots. So Q here signifies a material called quantum dot. Now what is a quantum dot? I'm going to explain this in this module itself. It is a type of, very specific type of nanomaterial, but the property of this nanomaterial is that if you keep that into some light source, it can emit light of various color just by changing the size. I talked about butterfly, that how butterfly ke wings ka jo layer hai, as the thickness of the layer changes from 2 to 4 nanometer, from 4 to 10 nanometer, it will start reflecting different color. In quantum dot, same thing happens. Just in this room, in this dark room, now it is dark because the light source here is ultraviolet. Our eyes cannot see ultraviolet light, but there is a light source in this room, which is ultraviolet light, but it can be some other light also. And in this room, which has some source, ultraviolet light source, in all these transparent liquid vials, we have kept quantum dots. And those quantum dots are of exactly same material. They are not different in terms of what they are made of. They are different in terms of what is the size of those quantum dots. Quantum dots here are of 1, 2 nanometer. Quantum dots here are of 9, 10, 20 nanometer. I have just changed the size and dimension. There is one light source, same material, size has changed, and all of these quantum dots are emitting different color, which is visible here. So I can literally produce color just by changing the size of a particular material. That I use one color, इस room में मान लो एक ही color है, white light है. I have quantum dots of different size, and all these quantum dots will produce different color here. This has applications in so many areas, but one of the most popular application is in that display TV. So that QLED display, that also has this LED, back LED, but now it has quantum dots, and those quantum dots can produce various vibrant color. The benefit of QLED is that it is not as costly as OLED, but its display comes very close to OLED. Now OLED even today has a better display compared to QLED, but QLED display, uska jo resolution hai, it comes very close to OLED display. That is another very popular application of nanotechnology in electronics. But these are very simple applications. Some of the most sophisticated applications of nanotechnology in electronics is, again, I will go back to this mobile phone. This mobile phone as of now is essentially a computer. Whatever software I can install on this laptop, I can find an app. In fact, I can find more number of apps than the number of softwares which are available on my laptop. आज से 10 साल पहले जो smartphone था, that was not very good at doing a lot of things. It used to hang a lot, run 2, 3 apps together, things were not good. But new mobile phones do not suffer from this problem, that I have 10 apps running here and it's working fine. I can easily transition from one app to another app. So it is doing many calculations, and all of those calculations can happen without lot of problem. Of course, it is going to drain more battery if I am doing many calculations together. But the point here is that how is it possible? It is possible because if I open this mobile phone and if I look at its circuitry, I will find transistors. And even in a very small area here, if you could count, you'll find few billion transistors. ट्रांजिस्टर्स आर लाइक डिवाइसेस, आप ऐसे समझ लो कि एक तरीके का स्विच है, एंड दैट स्विच अलाउज ऑल ऑफ द मॉडर्न कंप्यूटेशन. जो मॉडर्न कंप्यूटिंग की जब हम बात करते हैं, चाहे लैपटॉप हो, चाहे कंप्यूटर हो, चाहे सुपर कंप्यूटर हो, ऑल ऑफ दैट इज पावर्ड बिकॉज ऑफ ट्रांजिस्टर्स. ट्रांजिस्टर्स अलाउ इलेक्ट्रिसिटी इन सम डायरेक्शन, डज नॉट अलाउ इलेक्ट्रिसिटी इन सम अदर डायरेक्शन. I will not go into detail, but आप ऐसे समझ लो कि the transistors fuel all modern computing, and the more number of transistors I have, the better computation I can have. So this mobile phone, despite such a small area, it has few billion transistors, and those transistors are of nano dimension as of now. So those transistors are hardly of few nanometer. Now that is the most important application of nanotechnology in electronics, that I can make very small transistors, and I can put many transistors even in a very small area, and I can do lot of computation, simultaneous computation, without worrying about that my system is not going to function well, my system is going to hang. This is the biggest application. But there are other applications also, even in something called quantum computing, nanotechnology has applications. Write it down. Inflexible, bendable, foldable, flexible, bendable, foldable display, foldable display. Nanotechnology has applications. Nanotechnology has applications. Transistors next point, transistors, the basic switches that enable all modern computing, computing have gotten smaller and smaller through nanotechnology. Quantum dots, write down, next point, third point, quantum dots are being used in QLED display, QLED display, which produces vibrant colors, while being energy efficient, Quantum dots also have applications in solar cells, quantum computing, among others. I have some homework for you. The first homework here is, this is one of my favorite YouTube channels to understand about technology. The name of this channel is Wired, W-I-R-E-D, that's it. And they have this series of video where they explain one technology at 5 different levels. So they will explain a technology to a toddler, to a very small child, then to a high school student, then to a college student, then to someone who is pursuing PhD, and then lastly someone who is doing already a scientist in that domain. तो जो last का जो 2 level होगा, that will not be explanation, that will be more of a discussion about the technology. But जो first के 3 levels होंगे, particularly जो second and third level होगा, that will be quite useful for you. So they have this series of video on many concepts. They have this series on quantum computing, they have this series on blockchain technology. So I can recommend whenever I'm going to discuss quantum computing, blockchain technology in later classes also. And whenever I complete this topic, I highly recommend that you can watch these videos. Now this video, for example, in this video, it is a 24-minute video. You do not even have to watch the entire 24-minute. The last step you can easily skip. If you want to, go ahead and watch it. But I think very few things will make sense because they will talk about some of the most advanced research in the field of nanotechnology. Class is not over yet. Wait for 1 more minute. So they will talk about very advanced stages, but I highly recommend that watch the second, third, and even fourth. So second, third, fourth level. So the name of the channel is Wired, W-I-I-R-E-D, and they have this playlist called that an expert explaining a topic at 5 levels of difficulty. So rather than watching reels, you can watch this YouTube video, right? So do that, first thing. Second thing, another source which I can recommend here, the Department of Science and Technology, which falls under Ministry of Science and Technology, they have this website called indiascience.in. That indiascience.in, it is actually quite a useful tool because every week, for example, they have this 20-minute bulletin where they will talk about some of the most important technology developed in India as well as in the world. And they have also some really nice explainer videos about a lot of things. For example, I did a search about nanotechnology and I found these 2 very first videos. There is a video in Hindi, in fact, where nanotechnology has been explained, that what does it in Hindi. Or there is another video where IIT Delhi director is in conversation with one of the person and he's talking about what is IIT Delhi doing in field of nanotechnology. So you can directly jump to the last part of the video in the second video, that what type of developments are happening in our universities. So this is also a very good resource which can be utilized not just for nanotechnology, but in general it can be utilized for science and tech preparation, right? If you have any questions, you can ask questions from this topic till now, from the field of nanotechnology. Which display is good for eyes, QLED or OLED? Both are really good, but if I have to choose one, then OLED. But both are good. Both are good for your eyes per se. And none of them are good if you are watching it for very long. That goes without saying. In next class, we will, just one more thing, one more homework, sorry. Before coming to the next class, I want you to read few chapters from NCERT. I will be talking a lot about nature, so I will start communication technology in the next class. But before I jump into communication technology, I will be talking a lot about nature of light. So I want you to read at least few chapters. I want you to read the chapter on sound wave, जो 9th या 10th के NCERT में होगा, first chapter. I want you to read the chapter on light, जो 10th में होगा शायद. And I want you to read the chapter on electricity and magnetism, जो again 9th या 10th में किसी में होगा. So before you come to the next class, if you have to brush up the concepts about wave, sound wave, about light, second, and third about electricity and magnetism, then please do that before coming to the next class. You'll be able to understand it in a much better way. I talked to the classroom team what to do about basic concepts. And they had a suggestion which I agreed to it, that we will have this explainer videos. I will do that like a explainer videos. And that will be a half an hour explainer video or 20 or 30-minute explainer video about some basic concepts of physics and chemistry, which you already have studied, some concepts which you studied in 11th and 12th. And that will be uploaded on your portal. So we will not have separate classes for that, but very soon we will start recording these explainer videos, not more than 20-30 minutes, about basic concept. हमारे पास already videos हैं, but वो पुराने हैं, और वो 3-3 घंटे का ऐसे class है वो, तो उसकी ज़रूरत नहीं है मेरे हिसाब से. Technology is the most important part of examination. We can have simple explainer videos, not more than 20-30 minutes, and that will also be very useful. I will see you guys in the next class.